before going into the technical content of this technology, I would like to present some basic understanding, like how generally because everyone is talking about the e-mobility and electrification of all the vehicle, starting from two-wheeler, three-wheeler, four-wheeler, and then bus, right? But it is important to understand some basic calculation before we go for the design of the charger and design of the bus, right? So from that point of view, I just try to put some of the factors here. But here, let us focus only for bus point of view, because the bus is bit different from the other segment, like a two-wheeler or three-wheeler or four-wheeler, right? Because the two-wheeler or three-wheeler or four-wheeler, if you go for personal use, you don't have any fixed requirement from the vehicle. Like whenever you want, you take the three-wheeler or two-wheeler or four-wheeler, you go and then measure the charge, how much is the charge available in the battery, and put it back charge accordingly. So there is no kind of a fixed schedule is given or required for the most of the two-wheeler and four-wheeler segment, right? But when it comes to a bus, yes, there should be some fixed schedule. So all the calculations are based on the fixed schedule. So this is how we should design and do a pre-planning when we want to implement any charging solution for an electric bus point of view. So I put some of the parameter here. So let's consider that you have a two station, because always a bus is operating between the two stations, station A and station B. So the bus will be having a many trips between these two stations in a whole day. This is how generally a bus schedule and the bus principle of bus operating. Right, bus is not going wherever it wants, like our personal car. It is having a starting station, it is having a destination station B, and then coming back to A, which means that one trip is completed. So how many time how many hours, or what is the time taken for one round trip? Accordingly, you operate number of trips in a day between these two stations. This is how generally a bus operates. So based on that, so let's go to this some of the parameter. So first one, I put it as an electric bus versus diesel bus, because you know how the current electric diesel buses are operating. The buses will be put it on a depot in the night time, and in the morning, if it start at 5 o'clock or 4 o'clock or 6 o'clock, it's refuel the it fully fill the fuel in the tank diesel, and then it goes for many trip between the two station. Let's say in the afternoon, if the diesel goes below a certain level, then again it goes to the depot and fill the diesel and then continue the trip, and then at the night again it come back to the depot. This is what the one schedule of an electric bus in a day. So we want to have a electric bus operation also in the same way. Like the diesel will be replaced by a charge, electrical charge. So when the bus is starting from the depot, it should have a full charge in its battery. Then it keep on run in the route, and whenever the charge is down, it should be able to fill the charge as we are filling the diesel, and then should continue the operation for the whole day. It should not be the case that it goes for one or two trips and then the charge is down, and then you go and put it in your charger for many hours. So the operation is interrupted. The bus operation is interrupted. So this should not be the case, because we all understand that the main challenge in the electric bus or electric mobility is the charging time. Right? We cannot fill the charge or refill the charge similar to our diesel. We can put the diesel in maximum 5 minutes or 10 minutes in the bus, but that is not the case. So this is one of the big challenge that everyone knows that we have with this electric buses or electric mobility point of view. So what we want is, we want to replace the electric bus operation by an with the electric bus operation, the diesel operation in the similar way. We don't want to have any practical difficulties. Then coming to the second point, energy consumption or mileage. So for diesel or petrol, what is the mileage? Like maybe if you take, typically the diesel buses may take 4 to 5 kilometer per liter. This is what the general mileage. Maybe if it is an AC bus, maybe it will further reduce. So let's say 5 kilometer per liter. And then you can imagine what is the amount of liter you might be consuming for one trip. Similarly, we also have a energy consumption in terms of kilowatt hour for our electric buses. That maybe I put a typical value like a 1.5 kilowatt hour per kilometer. Then number of kilometer per trip, I assume that 22. You can see from A to B it is 11 kilometer, and for another trip from B to A again it is 11 kilometer. So I consider one full trip of 22 kilometer. So for we know that each kilometer it will take 1.5 kilowatt hour. So one trip has to take 22 kilometer, and let us assume in one day the bus has to go for a 10 trips at least, right? So 10 trips means total kilometer per day is become a 220 kilometer. Then if you take the 220 kilometer and multiply with our energy consumption, it comes around 330 kilowatt hour. So 330 kilowatt hour is the total energy required for your electric bus to run in this particular route between A and B continuously for with 10 trips in a day. Then 330 kilowatt hour is the energy required. Then what should be the battery capacity? So let's say we cannot drain the battery to zero at the end of the trip. We should have some battery SOC, I mean backup. So let us assume I want to keep always 30% of SOC at the end of the trip. Then if you put the 1.3 times of 330, you will land up in 429 kilowatt hour. Then you assume that you have to put a battery capacity of 429 kilowatt hour in the bus. Then only you can able to meet the complete one day trip requirement of 220 kilometer of a bus, right? So then you can imagine what will be the size of the battery and the weight of the battery that you have to install in the bus, right? Because in the morning you put the I mean you can come to the next charger. Let us say if you are putting a slow charger at the rate of 100 kilowatt, let's say, to fully charge that 429 kilowatt hour at the rate of 100 kilowatt hour, you will take around 3 to 4 hours. So let's say we are putting the bus in the depot for the night charge of more than 3 to 4 hours. Then yes, you will be fully charged with a. Now in the morning the bus is ready with a full charge of 429 kilowatt hour. Now you can start your trip, right? Assuming that it is exactly taking 1.5 kilowatt hour per kilometer and continuously running the bus for 10 trips. At the end of the 10 trips, you will lose 330 kilowatt hour. So you will keep remaining around 120 kilowatt hour, and you go back to the stop in the evening and then put it for a charge again. Right? This is one normal operation. Then also another thing, you need to calculate how many buses you need, because let's say the 11 kilometer takes 1 hour one way. The another 11 kilometer takes 1 hour another way. So for a bus number one to complete the one complete trip, it will take 2 hours. But you want to run the buses at a frequency, interval of frequency, like every 15 minutes one bus or every 30 minutes one bus. If every 30 minutes one bus, you minimum need 4 buses. Then only you can keep the frequency every 30 minutes is bus is available for a service, and also there is a continuous service for the whole day. Then the same charger have to feed for all the 4 buses. If it is 15 minutes once, then you will go for a double the number of buses. So this is how a one calculation for a complete day for a bus, and this is without considering any challenges, practical challenges, because we assume that 1.5 kilowatt hour per kilometer. Sometimes depends upon the road condition, weather condition, right? Even number of passenger. In one trip you may have 50 passenger. In one trip you may have 70 passenger or 80 passenger, right? So the consumption of energy is volatile or dynamics based on the many factor, right? So this is about a basic calculation if you want to operate a bus in a route in a day, right? Yeah. Then I go to the another slide where I calculate only one trip calculation. The big problem here in the previous slide, from my point of view or in general, you can see the total battery capacity requirement, which is 429 kilowatt hour. The weight of the battery is very high, and when you load more battery, when you have a more battery weight in the bus, then the 1.5 kilowatt hour will become more 1.7 or 1.8. So what you are doing here actually, instead of utilizing the energy in the battery for carrying the passenger, you are wasting some energy for carrying the battery itself, right? So that is one of the huge disadvantage of having a big battery in a bus and running it for throughout the day and only putting the charge in the night time at the depot. Okay, then how we can avoid it? I come to the one trip calculation instead of 1 day calculation. Again, one trip calculation, the energy consumption is say 1.5 kilowatt hour per kilometer, 22 kilometer per trip. So if I only calculate the energy requirement for one trip, it comes only around 33 kilowatt hour. Now I put even 50% of SOC. I don't want 30%. Even I put 50% of SOC, state of charge, my maximum battery capacity for one trip is 50 kilowatt hour. Now you can see how much the previous 429 kilowatt hour. Now for only one trip, I keep the energy in the battery, right? So 50 kilowatt hour is your battery capacity, and you can assume the weight, like the weight will be reducing 8 times compared to the previous case. Now you see the same charger, like for example, if you use the same 100 kilowatt power rating charger, you will need only 30 minutes to charge fully. Okay, maybe instead of 100 kilowatt, I increase the converter rating to 200. Then you can see you can reduce the charging time at the terminal 15 minutes, right? What I want to say here is like every time, like if the bus is starting at A, at 2, 3, 4, 5, in all the four stops, the bus will stop for at least 30 seconds for onboarding and offboarding the passenger, which we call it as a bus stop. And the terminal A and B, they are called bus stand in our case, where the buses will stop one minimum for 10 to 15 minutes, right? So we can make use of this, the stopping at A and B, just only for 15 minutes to recharge the energy in the battery to refill it and ready for the next trip, right? And the number of buses will be same in this case, right? So this is just a comparison between the 1 day calculation and one trip calculation. The big difference you will see here is that the battery size and the battery capacity and the battery weight, right? Yeah. Now with that basic understanding, let's go into the technical details. The flash charging technology from Hitachi ABB fully support this one trip calculation, or the method of how we are operating one trip. That's what I was showing in the video. A bus is coming to a bus stop and stopping for 30 minutes. Within 30 minutes, out of 30 minutes, in 30 seconds, in 20 seconds the bus can able to top up the charge. I won't say the bus is fully charged, it is topping up the charge, right? Like after one, I mean, you are starting with a 100%, and in the next bus stop you are getting 80% of charge, so you top up for 5%. So you keep on top up on the way, along the way. This is how the flash charging technology works. So let's go into the detail. So before going into the detail, I want to give a summary about what we were discussing here. The charging time is a major challenging factor for everyone, because if we are able to charge any of our vehicle in a maximum of 5 minutes or 10 minutes, I think everyone will like to migrate from our diesel or petrol vehicle to the electric vehicle, irrespective of the segment, either it is a two-wheeler or three-wheeler or four-wheeler or buses. The charging time is one of the mindset or mental model for us, which is stopping us to move from the conventional vehicle to the electric vehicle. So the major factor influencing are charging converter rating, right? As you see in the previous slide, 100, 200 kilowatt. Then if you further increase to 300 kilowatt, you will further reduce to 7 minutes. Then if you keep on increase the charger rating, your charging time will come down, right? Second one, number of chargers on the route for the buses, battery size, battery SOC requirement, and also the frequency of bus operation. So with this basic understanding and summary, we can move into the understanding the technology, how it works, and what are the converter configuration from the charger side, and what are the different types of charger we have, and what are the configuration required from the bus side, how the complete system starting from grid to battery is working in a coordinated way. So before going into that, any questions at this point, sir? Or can we take the questions now, or I will finish my presentation and we can take the questions at the last? Is that fine?
Yes, sir. Yes, sir. You can finish the presentation, sir. Finally, we can have questions.
Okay, sir. Thank you. If anybody
Okay.
have any
You can.
questions on a particular slide, please note down. You can come back and take the particular slide.
So otherwise, participant can post your questions in the chat box, sir. Okay.
Sure. Anyway, even if they are posting, I will be answering at the last. Yeah,
Okay.
we
Okay,
can
sir.
take it later. Yeah.
Okay, sir.
The charging options. There are three charging options in a complete solution. What we offer. One is a depot charger, terminal charger, and flash charging. So we need a combination of all the three for a optimum operation. So the first one is depot charger. You can see the number one in the picture. When the buses are in the depot, right? You can put the buses in the charging. It could be a slow charger. That's what we call it as a depot charger. The charging level converter rating is around 50 to 150 kilowatt, right? And if you only go for depot charging, you will need a large size battery, right? And you need to put the buses in the charger for around 6 hours at the rate of 300 kilowatt hour if you only go for depot charger. Then coming to the terminal charge, yeah, the converter rating is a little bit higher. You can go from 150 to 600. Medium size battery if you only go for terminal charging, and 3 to 10 minutes of charging for 150 kilowatt hour energy. So you can see the number two here. Number two is the terminal charging where the bus is stopping for 10 minutes. The source station and the destination station between which the bus is continuously operating. The third one, flash charging, where it will be installed actually. This will be installed at the bus stops where the bus is stopping for 30 seconds for onboarding and offboarding the passenger, where the converter rating is high compared to the other two chargers, and you will need only 20 seconds of, see, actually 20 seconds, why it was fixed is, normally the bus will stop at the stop for 30 seconds. So within the 30 seconds, we use 20 seconds. If there is a particular stop where the bus is stand for 60 seconds, you can charge for 40 seconds or 45 seconds also. There is no restriction. Right. And what you need is very, very small size battery, because you are not going to, you are going to charge this flash charge in every stop. So you no need to go for big battery. So you can see in the picture here, with the depot charger, you need more batteries or more buses. But with only a flash charge, it's more turnaround and more passengers, one of the main factor here. Here in the top depot charging, they called as a more buses. Why I see why it's more buses. Let's say in the first example, we put 429 kilowatt hour battery capacity. If you say that, no, I don't want to go for 429, I will only go for 200 kilowatt hour battery. So what you will do, you will only operate for the morning session. Then in the afternoon session, you will take the bus to the depot and put it on charge. To continue the operation, you have to send another substitute, alternate bus to the route to continue. So if you want to further reduce the battery capacity for a full capacity of operation, then you need to have a more buses to continue the operation. Because the most important requirement is when the bus is starting at 5 o'clock in the morning till 10 o'clock, we want to have a continuous operation of the bus to provide a service to the passenger. That is what the main requirement, right? Yeah. Now in our solution, we don't go for any one here. The best recommendation or the best solution would be a combination of all the three. Like, yes, we want to charge at the depot, we want to charge at the terminal, we want to charge at the flash bus stops. So that if you put all the three, you will get a maximum and a optimum operation, optimum charging of the battery. At the same time, your battery size or battery capacity will be very, very less. So it is explained in this slide. The first one, let's say you only have a overnight charging at depot. You can see 450 kilowatt hour is approximate battery size for the case study we discussed. You can see what is the weight of the battery, 4500 kilowatt. So only you charge it here, and then you keep on run the buses for the whole day, and again put for the charge in the night. Then here the charging time is very high at the depot. Second one, opportunity or terminal charging we call. Like for example, you see there is one terminal T, there is one terminal T. So we are installing a charger here in the terminal. In the previous first case, there is no charger in the terminal. We are installing the charger at the terminal so that instead of only charging at the depot, you have an opportunity to charge at the terminal also. So because of that, I reduce the further battery capacity and the battery weight. And you can see the battery size here. In the first figure, how the battery size is very bigger and the smaller one. And the charging time at depot further reduces because you are not going to the depot with a drain of charges with the 0% or 20% or 30%. You are keep on charging in the terminals. Now the third option, I have a depot charger, I have a terminal charger. In addition, I also put some flash charging at stops. You can see there are some chargers at the stop. So again further reducing the battery capacity requirement from 150 kilowatt hour to 80 kilowatt hour, which is only 800 kg. Now you can see the difference between the, the weight of the two batteries at the beginning at the bottom, 4,500 and 800. I hope you agree that weight of the battery, reduction of weight of the battery will increase the mileage of the bus. Either it will increase the mileage of the bus, or instead of for that weight, for the reduction of that weight, you can have more passenger. So if you have more passenger, more collection and more income, right? Instead of carrying the battery in the bus, right? And you can see further the charging time at depot is reducing. Now I take the only last figure. I explain. The battery is now starting with the battery is now starting. Just a minute. I'll just come. The 2 minutes. Yeah. So now the bus is starting from the terminal, sorry, the depot at 100% of charge. Now it is operating between the terminals, and whenever it stops the terminal, it is charging to some extent, like 10% or 20%. Then when it is going to the bus stop, again it is stopping, topping up the power for 5%. So what happened if you are keep on charging when you are running the buses for commercial operation? Then you are keep on topping up the charge in the bus. So when you come back to depot at the end of the day, you come with a maximum charge in the battery. It's not the case that you always come with a 30 to 40% of the charge or 20% of the charge. You come back to the depot with 80 to 90% of the charge. So your charging time at the depot is reduced very less, maximum if you put for 1 hour, right? So this is how the combination of all the three charger works.
Sir, it's not audible, sir.
Hello.
Sir, now only we hear your voice. Hello. Cut and repeater. Hello. Sir, it's not audible, sir.
Okay, sir.
Now it's okay, sir. Okay.
Okay, sir. Fine.
Okay. You can present the presentation.
Yes, sir. I hope now you can also see my screen now.
Yes, sir.
Okay,
Yes, sir. It's
fine.
visible.
Fine. Yeah, I was here in the configuration. You will have a battery here, and the battery will be continuously charged from the charger. And the DC battery output of the DC is connected to a charging pole, and then it is a bus. And coming to the terminal feeding station, the configuration is same except the energy storage devices in the middle. Otherwise, again, the charging will be through charging pole. And in the last one, we have a AC/DC charger, and then again you can charge it through charging pole, or here for depot charger, you will also have a CCS2 plug kind of charging. So this is what the converter configuration from the charger side. You will have a grid, the transformer, and a AC/DC charger. It is a rectifier basically. It could be a IGBT based rectifier or diode, not diode definitely. Either an IGBT based or thyristor based rectifier will be installed. So these up to these portion, starting from grid to the charging pole, the setup will be implemented in the bus stop. Right? This will be available in every bus stop, wherever you need to want to charge it. Actually. You can see the overnight charging at depot. You put lot of charger in the depot, and then you can see the SOC. You go to up to 10% of SOC before the end of the day actually, right? But here what you are doing, the second case, you are reducing the number of charger in the depot, but you are increasing the charger, the terminal charger in the terminal station, so that what you are doing, you are coming down at the end of the trip, but at every terminal, you are bringing the charge back to maximum for every trip, right? You can see the SOC of battery in different cases. Only depot charger, you keep on drain the battery. Then you have to go back to depot to bring the battery SOC to the original level. But here, you drain the battery, but at the end of the terminal itself, you take the battery charge to the maximum. Again, you start running the buses. So at the end of every trip in the terminal, you are recharging the battery by spending 20-30 minutes, and then you are continuing your trip. In the third case, you see, I have a depot charger and I have a terminal charger, and in addition, I also put extra flash chargers. You can see there are 3 flash chargers as installed in the way. So what is the effect is, when you are draining, at this point, I will take a, you can see at this point, you are topping up the charge. Again, you are running the bus. At this point, you are again topping up. The topping up may be 5 to 6%, not more than that. Again, you are running. Again, you are topping up. Now you can see at the end of the trip, with the top up of charger with the 3 terminal, At the end of one trip, you only land up in 45% of SOC, right? With the flash charger. But with the terminal charger, you see, you land up around 20%. Here also you land up around 10%, right? So while you are continuously charging on the route, your SOC will never go to less than 50 or 40%. Such that way you can design. And in the terminal also, you want to spend, you will spend only less time. Like for example, in the second case, if your battery is fully drained at the end of one trip, then you put the bus at the terminal for 30 minutes to bring back the charge. But in the third case, as you are topping up the charge in the way, you need to only put some 5 to 10 minutes in the terminal to bring back the charge, right? So in that way, you can keep on operating the buses in the route. The same buses can operate, right? And your number of buses will reduce drastically, right? This is how the combination of all the three chargers will work. This is exactly the graph, SOC graph. Let's say you are starting with the 90%, right? You are traveling on the distance. At the end of 2 kilometers, you are putting on flash charger. You can see this is a flash charge. You are putting a flash charge. So you are top of the charge by 5%. Then again, there is another top up, another top up, another top. So you can see 1, 2, 3, 4, 5, 6, 7. 7 flash chargers are installed in the route. So you can see because of that, at the end of one trip, the charge is only 50%. If you are not topping up everything, then the charge you might have done might have reached at 20%. So at the terminal, you need to spend more time to bring back the charge to the 90% or 100%. But with the flash charger, you see, you will have less time to bring back the charger. Again, the same curve will repeat for the round trip. And these are the, you can see, don't assume that this is the only stopping. You can see all the triangle of red or the stops. So you can see 1, 2, 3, 4, 5, 6, 7, 8. There are some 20 stops. Out of 20 stops between the two stations, we are putting the flash charger only at 7 station, right? Yeah. This again same, which is a simpler interface and reduced time to charge and reduced downtime of fleet, right? Yeah. Now coming to the difference, what is the difference? And coming to the bus side, now we understand. Maybe we will compare with the two things. Like one is the opportunity charging they call, then our technology is a flash charging. Now in the opportunity charging, you will have a AC-DC converter rectifier and also DC-DC converter in the charging station itself. So we call it as a DC charging. In this case, you can see this is a driving mode. So in the driving mode, you have an inverter in the bus, and the bus is connected to the inverter on the DC side, and the inverter is converting the DC into AC, and that is driving the motor, and the motor is driving the wheel. Now when in the charging mode, as you are charging DC mode, the DC is directly given to a battery and the battery is charged. This, when it comes to a flash charging, we have a converter which is a 2-in-1 converter. You can see, because there are two converters needed. One, the inverter when driving mode, and the other one, DC-DC converter when charging mode. Now we have in this technology, we have a 2-in-1 converter where a single converter will act as both inverter and a DC-DC charger. So during driving mode, or let us take during charging mode, it will act as a DC-DC converter and charge the battery, right? According to the battery SOC and the requirement of charge, everything, the DC-DC converter will charge the battery. When the charging is over, then the same converter will convert into an inverter. Then the input will be from battery and output to motor, and it will be driving. And it no need any communication actually, right? It doesn't need any communication. There will be only one part. Whenever the bus reaches the stop, before just 200 meter, there is one RFID. The RFID will be detected by the receiver at the stop, and then it will open up the power supply. At the same time, the robotic arm in the bus stop will also come out and ready for connection with the charging port. This is how the interface with the bus is happened in this technology. Yeah, you can just how the robotic arm is coming out. So the big one is the charging pole, which is installed on the bus stops. When the bus is approaching the stop, a robotic arm will come out and it will connect with the pole, and it will be charging the bus at the rate of 600 volt nominal voltage of DC charging. You will also find these videos in the YouTube. So you can see this is a rail, we call it as, and the robotic arm, we call it as a energy storage system. So the operation of the robotic arm energy transfer system is less than 1 second, right? And the also we take care of this is a 1 meter length of the rail. So even if there are some misalignment also, the connection will be proper. So it has been designed in such a way that if there are some mismatch in the bus alignment, so it will still take care to position with the rail actually. Coming to the bus says that I transport more passenger than batteries. This is what the core concept of the technology. And previously the technology we call it as a TOSA, TOSA, the brand name. Now it has been recently changed as flash charging technology. You have a wheels. The wheels are driven by the motor, and the motor is driven by the inverter, right? And the same inverter will act as a DC-DC converter for charging these batteries. And the battery has been charged via the energy transfer system that we call it as a robotics or ETS. And one more important point here, the battery used here is a special purpose battery, which is we call it as a LTO, lithium titanate oxide battery. It is something different from our regular battery, which is having a 5 times higher charging capacity or higher charging speed compared to our lithium ion battery and other batteries. Because you can have a power electronics converter or charger at any power level. Ultimately, whether your battery is capable of accepting the same is more important, right? So from that point of view, the LTO battery is especially recommended for this. Yeah, the same I was just showing the previous slide, the energy transfer system, the robotic arm. The robotic arm is connected to a DC-DC converter and then to a battery. And yeah, so this is one of the bus we deployed in Europe, and now this project is successfully running in many places in the country. And currently we are also working one of the pilot project in India, especially in Chennai. So that also the news also you will get soon that one of the flash charging pilot project is going to run in IIT Madras campus very soon in the collaboration with Ashok Leyland, Hitachi ABB and Ashok Leyland. This is about the installation at the bus stop, what and all you need. The main important thing, the 7 and 8, right? The 7 is the energy storage system, the battery I said, and the 8 is the control panel and the charger and the SCADA system, and the 9 is the pole, right? The 7 and 8s are connected to a grid, and through 7 and 8, the charging cables are taken via the charging pole and the U rail to which the connection is made, and you can see the robotic arm is connected, and other things are installed in the bus like the battery, DC-DC converter, and in this is one of the sample from Europe, and in Europe most of the onboarding equipments are placed in the roof, but in our case it will be in a chassis. A quick comparison, a depot charger and terminal charger and a flash charger. A quick understanding in terms of time. The depot charger will need minimum 3 to 4 hours or 5 hours for one battery fully to charge. And the terminal charger will need only 5 to 10 minutes. Right? Flash charge in terms of seconds you can charge. So if you go with only only individual charger, only depot charger, only terminal charger, and only flash charger. This is how the comparison has been made. You need a more number of buses with the depot, medium, but less number of buses comparatively with the flash charging. And with only depot charger, the passenger capacity is very, very less. And you can see the flash charger, it is double or proportionally increased. The battery size is big with only depot charger, but with flash charger, you can see you can drastically reduce the battery size, weight, and then you can carry more passenger from there. Terminal charger and depot charger, you can see more charger, right? More terminal, only depot charger, no terminal charger here. But here, it's a trade-off. You can have a 50-50 of terminal and depot. But if you go with a flash charger in addition, then you can drastically reduce the requirement of terminal and depot charger, right? And then availability of the service in the route. You can see maximum availability, almost 95% availability with the flash charger. Peak electricity demand. Yes, this is one of the important factor. If you are putting 100 buses at a time in a depot for a charging, then you can understand what will be the load on the grid and how much power will be consumed at a time as a peak demand from the grid, which is too much with a depot charging. But it is not at all a case with the flash charging because you distributed the charging. You are not charging, you are not doing accumulator charging, you are doing a distributed charging. So you charge along the way. The charge has been done randomly at different places in the city so that the peak demand is not accumulated at one point of time and one terminal on one grid side. This is one of the great advantage of having a flash charging. Initial investment, yes, it is a bit more because the number of chargers are more because you need to install more charger on the way side. But the operation cost is very, very less. Right? Yeah. So this is a comparison individually. But ultimate solution, good solution will be a combination of all the three, right? Exactly like a terminal charger and a depot charger. In that point, you look at the displays actually. Now you have a flash charger. Along with that, you have a minimal number of terminal charger and minimum number of depot charger, which will have a very good trade-off in all the factor that we compared or discussed here. Coming to the energy consumption, just I was talking in the previous slide. I'll just show one example here. Driving distance. You want to drive a 250 kilometer per day. It could be within a city of multiple trips or between a city. It is intra-city, which is a 250 kilometer apart. And the total operation hour is 18 hours, let's say. Now, 250 kilometer at the rate of 2.5 kilowatt hour per kilometer, then your total energy requirement per bus is 625 kilowatt hour per bus. Now we say that you are going to operate 100 buses for 18 hours. So for every bus, the total power demand will be 3.5 megawatt. Now let's say you are putting all the 100 buses at a time in a depot charger, in overnight charger for 3 hours. And what will happen? The peak demand to the grid from the load is 21 megawatt, right? Now, if you put a 3-hour charger, it is a 21 megawatt. Okay, instead of 3-hour charging, I made it as a 5-hour charging. Then your demand will reduce to 12.5 megawatt. Now you can see this is a huge power demand at a time or peak demand at a time to the grid when you are putting a overnight charging of 3-hour or 5-hour. Instead, let's say we put the charging at the stop, right? This is you can see this is only between night 12 o'clock to 3 o'clock. Similarly, this is only between night 12 o'clock to 5 o'clock. Within this time period, this is the maximum peak demand to the grid. Now we are not at all putting in the morning time. We are only putting the charge at the stops. Now you can see the charge demand at any time is reduced to 7 megawatt. Now we are again putting more. This is only a terminal charges. This one with a flash charger. Now you are further reducing the total power demand to only 3.4 megawatt, and also it is a distributed. So it is very clearly given to the grid operator that my maximum demand, peak demand from the load is will not exceed 3.5 megawatt, so that the infrastructure plan can be planned accordingly. But in the previous case, you can see the infrastructure requirement 21 megawatt and 12 point megawatt. So with a flash, the message here is that with the flash charger, you can also reduce the peak demand to the grid. And you can ask, with the flash charger, we are charging at the rate of 600 kilowatt, right? Which was shown in the first video. The video shows that you are charging for 20 seconds at the rate of 600 kilowatt. In that case, is the 600 kilowatt is not a peak demand? Yes, true. But to take care of that, you might have seen on here in the flash charger, you see I have shown one energy storage unit. So it is not a direct charging from the charger to the pole. We are keep on charging the battery or energy storage unit through the rectifier, and the energy is transferred only from battery to the battery via this, so that we are avoiding the any peak demand to the grid. So the grid will be having a constant load to only charge the battery that is put it on the station. So whenever the bus comes, the only the energy or the charge available in the battery is transferred to the battery in the bus via charging port. In that way also we are avoiding the peak demand to the grid actually. This is about the power demand. What are the different advantages, like benefits with the flash charger? Timetable, starting from the 5 o'clock in the morning to the 10 o'clock in the evening, you can continuously operate the bus without worrying about the ideal time of the bus. It will exactly replace the current operation of diesel bus. Right? Whatever the number of trips schedule you have for diesel bus, it will exactly replace, because whenever the diesel is over, you go to the depot and you refill from the petrol bunk or diesel bunk. Similarly, here also the charge in the buses keep on top up, right? And that's a big advantage to maintain the timetable, and you can reduce number of buses requirement. And the second one is high passenger capacity, right? Because you are reducing the weight so that you save the mileage, so you can onboard more passenger. And most important is long life of the battery, because it is fact that the battery life is mostly depends upon how deep you discharge. You always discharge your battery only up to 50%. So don't allow the battery to discharge below 50%, and you keep on charge it before it crosses 50% of SOC, then your battery life will improve. Instead, if you drain the battery every time to 10%, 0%, and then you recharge it, then it will definitely reduce the battery life. So in that way, with the flash charging technology, we are not allowing the battery to drain or discharge below 50%. That will improve the battery life. Grid compatible, that we just discussed. Light infrastructure at depot, because as you have a distributed charger installed at the bus terminal and the bus stops, you can reduce the number of charger requirement at the depot, because you don't need to put the bus or charge for 3 hours, 4 hours, because already the bus is going to come back to the depot with 80% or 90% of the charge. You have to put only for 30 minutes or 40 minutes to bring back the charge from 90 to 100%. That's all. So it is good to have only a light infrastructure at the depot. Yeah. Now we can understand from the discussion, if we want to implement or convert our conventional diesel buses into electrical buses, the planning, the design should be only done based on route. You cannot have a generalized solution. Okay, you install the charger every 2 kilometers. You install the charger wherever you want. So we cannot go like that. For a bus operation, it should be only based on the route cases. What is your starting route? What is your ending route? Between which, how many trips you want to run in a day? What is the road condition between the two stations? How much will be the mileage of the bus with the battery? So all this factor you have to put together, and the planning, the infrastructure development, when you want to convert a bus into electric bus, it should be planned only based on route basis.
It cannot be generalized, like not like a petrol bunks. Like you install the petrol bunk wherever you want. When the bus is going, it can refill wherever it wants. It will not work like that. So it is completely based on the route based calculation. The designing, planning, everything should be done on a route basis. So it is very important to do a pre-calculation and pre-planning. So we also have a tool which is like a web-based tool using like a Google map. Like you can go and select your stopping, I mean starting stopping and ending stopping, and how many stops you want to have in the middle. So it will take all the information from the Google map, and it will finally suggest you for this route what should be your battery size and what should be your number of buses and what should be the, and also it takes the weather report, and also it takes the passenger density depends upon the route and the time, and also it takes the road condition, whether do you have any flyover in the route, right? Because definitely due to the flyover you will have a more drain of the battery, the consumption of energy is more. So by considering all this route, it will give a initial plan to simulate the complete system before going for the infrastructure deployment, which is very important. Not only that, we also have a asset management and the SCADA system, right? Because we are going to manage many charging stations, and we have to make sure that every charging stations are in operating condition and there is no fault, and also monitoring the asset and the status of the equipment installed in the bus, like a battery charger, right? So everything. So that is also as an integral part of this complete solution or system, I would say. There are some information is required for vehicle dispatcher, infrastructure manager, workshop engineer, and a traffic controller. A complete system should be organized in a digital way. Right? These are all some of the example project that we have already implemented in the world. Geneva, Geneva, Switzerland, we have a first project installed where you can see the bus size is 18 meter. It is a double articulated bus which can carry the passenger of 133, and there are 50 stations, out of which 12 stops were equipped with flash charging. You see, there are 50 stops between the two stations, but you don't need to install in all the 50. You can only install in 12. That 12 is decided by the or designed by the tool. And also another one from France, which is a even bigger bus, like a 24-meter bus, and only 6 out of 33 stops were installed with the flash chargers. So with this, you can continuously run the route 18 hours continuous operation by just keep on charging the battery along the route. No need to worry about the charging the battery. And another one is coming up in Australia, which is a Brisbane, which also a metro plus bus. So this is what I wanted to present about the flash charging technology for a sustainable electric bus operation, mainly for a public transport operation. Just before taking the questions, we can also see some of one more video. This is the actual project implemented and how the bus is coming to the stop, and how the charging is done in a bus stop. The bus is coming to the stop. You will see one robotic arm will come out now. Yes, it is ready. Then after stopping, it will go and connect with the U-rail. Now the passengers are onboarding and offboarding the bus in the bus stop. In the meantime, the charging is done. Charge is done now. That's all. So now the charge the charge might have topped up to 5 to 10% actually. So if you keep on doing this for every bus stop, you no need to worry about the charge drain from the battery, and you can keep on operate the bus for the throughout the day. Which is the, I feel that from the public transport and the bus operation point of view, this is the best solution we will have for a long term point of view, right? You will use less battery capacity, and you will use more passenger to carry, and you will use only less number of buses, right? It will reduce the number of bus requirement, but only the infrastructure investment at the beginning, and the running cost is also very less. Yes, sir. This is what I wanted to present, I think, for today. Maybe if you have any questions, I can take it.
So participants can ask any questions if you have.
Maybe I can just go through the. Is there any possibility to stop overcharge of battery? Is there any possibility to stop overcharge of battery? Flash charging can overheat the battery if it is possible. How we will overcome that, and what material we can use? As I said already, the battery used is not a normal battery. It is having a 1C or 2C speed of charging. It is a lithium titanate oxide LTO battery. You can note down and you can search in the net. It is a LTO batteries which is having a 5-6 times more charging acceptance capability. Only with those battery it will work, right? And you mentioned about overcharge. No, you have an onboard converter. The onboard converter will perfectly take care of your charging level, because we use a buck boost converter in the onboard, right? Based on your charging level SOC. Let's say if your nominal voltage of the battery is around 600 volts, we are also providing the charge at 600 volt. Now the battery voltage will be 900 around when it is fully charged, and it will be around 400 when it is fully not charged. So your DC-DC onboard converter will take care of the varying the charge voltage of the battery according to the charge level. It will initially it will apply a 400 volt. The current will be more. It will work on a constant power more, and then when the charge is getting increased, the voltage will be reduced. The voltage will be increased and the current will be reduced. So the DC-DC converter will perfectly take care of the charging of the batteries. Flash charging basically based on large value of current flow in a small fraction of time. Yes, we are pushing more power. When the battery is capable of accepting is, yes, we are ready to do that. But we cannot do more than the battery capacity. Now we put it here 600 kilowatt, but 600 kilowatt the power rating converter, which is an acceptable level for the LTO battery. We are not putting 1000 kilowatt or 2000 kilowatt, right? Whenever the battery is ready to accept more power, up to that level we are defining it, so that we can push more power into we can push more energy into the battery with less time. So is the system choice of insulation is quite important. Means it is taken care. It is taken care well about the installation part and everything within the charger, as well as from the bus point of view. Right? I don't think there is a really any special insulation is required. Like whatever in the power level, like what you want to have an insulation level for 600 volt and 600 kilowatt, all the insulation is taken care here. Actually. The ultimate thing is like you have to believe that the battery is capable of accepting the charge. So nobody is stopping you to push the charge at the power rating of 600 kilowatt. How many motors are used in the bus? It depends, because there are different size of the bus. We have a 9 meter, 12 meter, 15 meter, 18 meter, 24 meter. So there are different size of the bus. So depends upon the size of the bus, and accordingly you will use number of motors. It is not fixed actually. So if you do a flash charging, the lifespan of the battery is shortened due to overheating. No, the heating is taken care by a proper cooling mechanism. The battery is a water cooled battery here. So similar to your converter, similar to your semiconductor, the battery is clearly taken care of overheating. So perfect cooling mechanism and cooling requirement is done. So the heating problem is taken care here. Okay, I think these are all the questions I see from the. Uh, so if you have
Sir, I
any
have a
other,
question.
yes, sir.
Yes, sir, we have a super capacitor, sir. No, sir. It has fast charging capabilities.
Yes, sir.
Okay, what could be the C rating of super capacitors we use today, sir?
I think it is also similar to LTO. I think like a 5C or 6C. I understand.
5C or 6C?
Yeah.
Okay,
From
sir.
lithium ion, it is around 1 or 2C. But I know that the difference between the lithium ion and the LTO batteries are at least 5 times. It can accept the charge more.
More. It has a
Yes.
5 times more C rated than lithium ion.
Yes. Yes.
Okay, sir. I have an idea that for a flash charging, instead of charging a single large size batteries, charging multiple small size super capacitors can be used to flashly charge. That mean because that has a more self discharge capabilities. It cannot hold more power for longer time, but it can be charged to its maximum capacity over a short duration. So why don't we charge these super capacitors at a point with a more number of super capacitor and charge it back to these uh, huge batteries in our system, so that
We
we
can do
don't
that.
need.
We can do that. We can do that. See, if you want to carry a backup charge, right? Like how we use a power bank for our mobile and everything. Yeah, super capacitor could be a good choice to keep the charge in your in a capacitor, and then wherever you need a quick charging, the transfer of charge between the super capacitor and battery can happen. But we need to create a case study actually. We need to create a, because these are all the ideas, but
Yes,
in which case study it is really giving a good benefit. So definitely this can be explored, but we have to identify a right case study for this actually. Because we cannot propose some solution like this blindly, right? Okay, now
yes, yes,
yes,
yes.
we have a super capacitor, but yeah, I mentioned that you can use a capacitor. We use a capacitor or energy storage device in one of the station. There it could be a super capacitor. You can put the super capacitor there. But whether you can see whether you need a super capacitor or there now, right?
Yes,
Yeah,
clear study about super capacitor can help us to have these ideas.
exactly. Whether this super capacitor is the only way to give a solution here, or whether the normal battery also can give. If the
Yes,
super capacitor is the only way, yes. But if the normal battery also can give, what is the difference? What is the cost factor? What is the performance factor? So whether we really need to go for a super capacitor, those things have to be analyzed and discussed, and then it could be floated as an idea. Actually. I mean, there is no
okay.
restriction of whether only to use a normal battery or super capacitor or normal capacitor. We can do that, but
No.
we should have a case study whether there should be a requirement in the customer, requirement from the market. That is more important for any of our idea to bring it to a reality.
Yeah, yeah, yeah. Actually, you said about buses can be charged when it is deboarding or boarding of passengers. It may take maybe a minute. Maybe a minute if it is giving us 4 to 5% of charging. SOC is getting increased. Over a time, where a super capacitor can be charged, multiple super capacitor can be charged for almost 80% within, because it can accept more power, high current capacity it has. So it can be accommodated into these large vehicles because it is not small. It has a lot of space to accommodate. So when it is traveling, the super capacitor can be used to charge back the batteries which drive
Definitely
our
you can do
vehicle.
it. Definitely
Yes.
you can do it. Definitely you can do it.
Okay.
Like in our solution, what we are doing is we are directly charging the LTO battery, which can
Hmm.
accept the charge in a faster way.
Okay.
Now your proposal is if I don't want to LTO battery, okay, put a normal battery. Instead, you put an additional super capacitor and charge a super capacitor in the terminal. And then now what is the complication here? In the first case, the driving mode and the charging mode is different, right? Now in
Yeah.
your proposal, the charging mode and the driving mode will be simultaneous actually.
Yeah, it's
So
true.
accordingly, the infrastructure in the bus has to be modified. So battery
Okay.
should be capable of charging and discharging simultaneously. So those are all the practical implementation. But otherwise, concept wise, yes, it is good. But practically, how to bring it, that's more important. Yeah,
Okay.
the
Is there
driving mode and the
anything?
charging mode, the driving mode and the charging mode will happen simultaneously.
Yeah, the battery management system we have to concentrate on here.
Yes.
Okay. Thank you. Thank
Yeah.
you.
Thank you.
Sir, what would be the cost of the battery, sir?
5 times more than the normal battery.
Usually 5 times more than that of the normal battery, sir.
Yes, this particular LTO battery.
Okay, sir. Thank you, sir.
How much unit will consume during each station? Yeah, you can see how much kilowatt hour we consume. Like if we consume 6 kilowatt hour in every station, then it's 5 unit. What is the advantages of going wide band gap switching devices in converter topology? Okay, you can operate at very high switching frequency. Your losses will be less, and your temperature, definitely the operating temperature, junction temperature is one of the main constraint for silicon based semiconductor, which is around 125 degree is the nominal junction temperature, maximum junction temperature. And nowadays with the improved chip technology, we go up to 150, 175 kilowatt, 175 degrees Celsius. But with this wide band gap is silicon carbide you mentioned, we can operate at very high switching frequency. That is one advantage actually. But you have to see the cost also, whether the cost of silicon carbide is giving benefit equally to the what for it is used actually. Yeah.
So any other questions from participants?
I don't
So-
see any other question in the chat box.
So if you have any other question, you can ask. Otherwise, post in chat box.
Okay, sir. One more thing. That if we want to do some R&Ds, do you have any provision in your thing for doing those things?
I don't understand. Like, if you want to do R&D means, I mean, where you are working and what is your expectation, what is your requirement? Because you also do R&D and we also do R&D.
Yeah, you do R&D, not like that. If I have an idea, do I have any platform to be tested my idea over your company like that? Will you provide anything options?
In what mode we are going to collaborate, that is more important because like generally you are from academic, right, sir?
Yes, yes, yes.
Okay. When it is an academic, generally there is an internship program and a project, right? And also where you are working like a, I mean, we have to define clearly what is your area. I mean, are you a master or doctorate, sir?
Doctorate. Sir.
Doctorate. So if you are a doctorate, then you are working from an academic. We have to discuss that, sir, because different types of programs and different types of mode of collaborations are available between academic and industry. Like it is also depends upon your institute, right? We have some collaboration with some of the institute. If your institute is one of that, then no issue. But if it is not, then we have to see how the collaboration
Collaboration can be made. Yes.
Yeah.
Okay, I can understand. Okay, thank you.
From which institute you are, sir?
KPR Institute, Coimbatore. Sir.
Okay.
Thank you. Sir.
Generally, the student internships are happening.
Okay.
First preferred one is the student internship, at least master level, because for this kind of R&D, master level would be good, more of a power electronic side. So generally, this kind of collaboration happening in that way, like people come for a student come for internship for 6 months to 1 year, and then they work in this kind of technology. This is one I see a regular way of collaboration.
We do with the student collaborations, and then we used to present in some product demos, so ideologies. But what I required is some platform, because already you have some well-built platforms. Some institutions have made some MOU and they were working on with some center of excellence. So we too have some center of excellence centers, but I just asked you about, is there anything that
Because
privately
it cannot be done one to one, because you also are involved attached with an academic institution, and we also are attached with an organization. So there are many organizational aspects are there. Only it can be discussed from that point of view than more of an one to one. One to one, maybe if you ask, like if you contact for any kind of technical queries and things, that we can always answer actually.
Yes. Okay, thank you, sir. Thank you.
Any other questions from participants?
I hope it is useful, and also maybe introduction of a new technology. I don't know whether you people are already aware of or heard about this technology.
So it's very useful session for us, sir. So it's a very newer concept. It's a different perspective towards the electrical vehicle technology. And thank you for your wonderful session, sir. So participants, keep on touch with our expert through their mail ID and phone number. If you have any doubts or anything, you can contact our expert in future for your research and for other works. Okay, thank you very much, sir.
Thank you, sir. Thanks for organizing this, and thanks to all participants. Have a good day.